All right, we're back. We're looking at an example from the book. Hi, Chris. Everybody say hi. Okay, they all miss you. Yeah. We're looking at number 51 from page 147 in the textbook. All right, I need a reader. Who's going to read?
Do I read all of it? Okay. Okay. When a diabetic takes long-acting insulin, it reaches its peak effect on the blood sugar level in about 3 hours. This effect remains fairly constant for 5 hours, then declines, and is very low until the next injection. In a typical patient, the level of insulin might be given by the function defined by where T is the blood sugar level in appropriate units at time T measured in hours from the injection time. Chuck takes his insulin at 6 a.m., finds his blood sugar at, hey Chris, I sat by you today and you didn't sit by me, so whatever. And the rest of the listeners that are gonna listen.
Part A, what is it we're trying to find? 7 a.m. And we need to put the function up. So we have f of, is it f of t? Okay, and why do you think they chose t? T is time. So we're plugging in a time. So these are our times over here. And what are our pieces? Our first piece is what? 40t plus 100. And that's for what times? So between 0 to 3 hours. Okay, good. And then the next one, what do we got? 220. All right, and then after 220, how much is it? What's this number right here? 8. So we've got 0 to 3 hours, 3 to 8 hours, 8 to 10 hours, and then what's next? Awesome. Okay, so when we say 7 a.m., am I going to put 7 in for T? No, why not? It's an hour. And how do we know it's an hour? What's at 6? Okay, yeah. So that's crucial. So the injection was 6 a.m. And so our T is equal to the 7 minus 6, or 1 hour. So what's his blood sugar going to be at 7 a.m.? No. Look, 1 hour. So even though it's 7 a.m., it's only been 1 hour. So we plug in the time of 1 hour, 140. So at 7 a.m., it's going to be 140. The correct units are not in the problem, but it would be mgdl if you're in the United States. That's milligrams per deciliter. All right, so B, what's the time? 3 what? Oh, 9 a.m., which means 3 hours. Is that right? And so it's still the same range, but is it going to be the same blood sugar? No. Is it 220? Okay. And we got that from 40 times 3 plus 100. I'm going to pause the video right here and work out the rest of them. All right, so let's go ahead and do some of the points. What was the next time? 4, T was 4. And what was the blood sugar? Okay, what was the next one? T equals 6. Yeah, what was the next one? Ocho. Multilingual here. What do we get there? 220? Look and see what's next. And what was it there? 60. Was it any more? 19, 18. And 60 again? Is that the last one? Okay. Is there like a question at the end? Yeah, so that's a really good question because we've talked about whether graphs are continuous. So we'll hit that real quick. So yeah, we graph it, and there's basically four pieces. What should we put along this axis? Our time. Always put t or our time down here. And so we'll start at 0 time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we'll go, what's over here? Blood sugar levels. Ben calls everything related to my diabetes blood sugar. Like, if I'm eating a snack, is that a good blood sugar? Yeah, it is. I don't know why I'm adding that to the video, but yeah, shut it. No. Okay, so we need to go up here. You're going to enjoy this moment before you get out. We need to go up to Julian, yes. So let's go up to what number? What do we need to get to? So I'll go by like 25. So this will be 225, this will be 100, and this will be 225 up here, something like that. All right, so when we graph here, we've got the function 40t plus 100. That means what's the y-intercept of this first one? Look at this first portion. What would our y-intercept be? 100, and it has a slope of 40. So we're going to start our graph right at 100, and it's going to go up 40 over 1. If we look at our points, when t was 1 at the beginning, our f of t was 140 because it goes up 40 over 1. When t was, and we're just plotting number of points, when t was 3, we had 220 all the way up here. And then it stayed flat at 220 through 4. So 3, 4, 5, 6, 7, 8, all the way across here. I missed it. Scoot that over. And then once we get here, we get a slope of what? Negative 80. So that means that from here to the next ones, we had a slope like at 11, it was down to 60. So 9, 10, 11, 25, 50, somewhere in this area. Yeah, I might need a. I know how to fix this. There's some kind of interference in the back that makes that like sense that it's somewhere else. I don't know. And then it's flat 60 from the rest of the time, right? So for many diabetics, this is an issue where because of the way the insulin works, when you eat, even though you've taken the insulin, when you eat, all that food is absorbed into the bloodstream and the blood sugar goes high for a while until the insulin's able to absorb it into the body and then it returns back down to a normal level. But the thing to remember from the algebra is that when we have different pieces of the equation, just like up here, this piece has its own graph, and this piece has its own graph, and so on. And each piece kind of helps form a total overall picture. Okay, you got it?